Now, let's substitute this into the right-hand side of this phase equality relationship. So what we would get, so let's plug in here. And so what we would get for the phase would look like this. It would be 2 pi over lambda prime x minus vt. I will just put a factor of gamma over here, where gamma is 1 over the square root of 1 minus v squared by c squared, plus, times cosine theta prime plus y divided by y sine theta prime divided by lambda prime plus gamma times the frequency prime times t minus vx over c squared. So this is the phase of S prime, or the right hand side of that equality. And now we can collect all the terms which have x in them. So we collect all the terms which have x in them, and we can write them like this: gamma cosine theta prime by lambda prime. There's an x here, and then there's an x over here. So we can write this as, we can pull out the gamma common to both those terms. So gamma cosine theta prime lambda prime minus nu prime v over c squared and then times x plus, now we'll collect the terms with y. There's only one term, which is sine theta prime by lambda prime. And we collect all the terms with t. So first we'll write this one plus gamma times nu prime, and then we take this one minus v over lambda prime cosine theta prime times t. Okay, so this is the phase, and this phase, so now we equate to the phase as seen by S, and that phase is 2 pi x cosine theta by lambda plus y sine theta by lambda plus nu times t. I think I made a few sign errors here. This is minus the frequency, so I'm just going to write this as minus sign. So that would correct the sign over here, and there would be an overall minus sign here and a plus sign over here. Okay, so now the thing is that these phases should be equal at every space-time point. Okay, so what that means is the coefficient of x should agree, the coefficients of x on both sides, that is, this coefficient should be the same as this coefficient, and similarly the coefficients of y and t should agree. So what that gives us is gamma times cosine theta prime over lambda prime plus nu prime v over c square is cosine theta by lambda, and now equating the coefficients of y, sine theta prime by lambda prime is equal to sine theta by lambda, and equating the coefficients of t, we get gamma times nu prime plus v cosine theta prime by lambda is equal to nu. And now we can use relationships between nu prime and lambda prime. So using the fact that c is equal to nu prime lambda prime, and using the definition of beta, which is v by c, we can rewrite these equations in the form gamma times cosine theta prime over lambda prime plus beta over lambda prime. So I'm just going to pull this out common, beta over lambda prime. So this is just rewriting this first equation, is equal to cosine theta over lambda. And the second equation is sine theta by lambda prime is sine theta by lambda. And the third equation is gamma times, sorry, this is lambda prime. So this can be written as c over lambda prime plus beta c cosine theta over lambda prime. So again, I'm going to pull out the lambda prime as common. And if I divide both sides by c, then I can write this as 1 plus beta cosine theta is equal to nu over c. Or rather, if I move the c over here and write c by lambda prime as nu prime, then I can write a relationship between nu and nu prime as this. Okay, so there are three things that we want to solve for. We don't know the wavelength as measured in frame S. We don't know the frequency as measured in frame S, and we don't know what angle theta the wave makes with respect to the x-axis in frame S. Okay, so we need to solve for these. Sorry, just some primes missing over here. There's a prime over here, and there's a prime over here. Now, we want to solve for these in terms of lambda prime, nu prime, and theta prime. But we also have a fourth relationship, which is lambda times nu is c. Okay, or which is the same as lambda prime nu prime. And therefore, we actually have four equations that we have, which we can use to solve for lambda, nu, and theta. And that must mean that one of these equations is redundant. Okay, so what we can do is we can divide let's just number these equations. So 1, 2, 3, and 4. So to solve for theta prime, we can just simply divide equation 2 by equation 1. And what that gives us is sine theta prime over gamma times cosine theta prime plus beta is equal to tan theta. Okay. And the last equation tells us nu in terms of nu prime. So this is an equation which solves for theta. Okay, so this is the solution for theta. or tan theta is equal to sine theta prime square root of 1 minus beta square over cosine theta prime plus beta, where I've just used gamma is 1 over the square root of 1 minus v square by c square. Okay, so this tells us the solution for theta, and the solution for the frequency is directly seen from the third equation. Once we know theta, nu is nu prime times 1 plus beta cosine theta over the square root of 1 minus beta. Okay, and the wavelength, of course, is just c by nu. Okay, so what we're really interested in is these two quantities. What is the angle that the light ray makes as seen in frame S, and what is the frequency of the light ray as seen in frame S?